Good evening. Apologies for the late start there. We will let everyone into the presentation and then get going shortly. Buttons are touchy, Sue.
Yeah, let's see, I just changed to.
And I ask that everyone remain muted and turn their cameras off while we are presenting, and you will be able to unmute and turn your video on once we start the Q&A at the end of the presentation. This talk is being recorded and will be posted to our YouTube channel on a later date. It looks like we don't have very many more people coming in. So with that being said, good evening, and thank you for attending this evening's virtual lecture. My name is Galen Kinsey, and I am the scheduling coordinator at White Mountain Research Center. This talk is being recorded and will be posted to our YouTube channel at a later date. The link to watch will be posted on our website at WMRC.edu. And as a reminder, I ask that all participants remain muted and keep their cameras off during the presentation. We will have a Q&A session afterwards where you can either raise your hand or ask a question in the chat. Firstly, I would like to give a land acknowledgement. UC-WMRC acknowledges the Numu, Paiute, and Niue Shoshone as the first peoples and traditional land stewards of Paiuhenadu and Koho, the Owens Valley and White Mountains. As a facility managed by a land grant institution, we pay our respects to the elders and relations of past, present, and emerging. With that being said, I would like to introduce this evening's speaker. Sue Burak is a hydrologist, avalanche scientist, and consultant. You might know her as a former avalanche forecaster for the U.S. Forest Service. Tonight, she will be presenting her recent research titled, Guess Who is Coming to Stay? That was like an understatement, huh? Impacts from an extended visit by a family of atmospheric rivers, in which she will discuss ongoing efforts to unravel the relationship between specific weather, climate, snowpack factors that contributed to numerous large magnitude avalanches during December 2022 and January 2023. Sue, you have the podium.
Thanks for that, Galen.
You're welcome.
So when Galen and I first started talking about this presentation, it was in January or February. And at that point, for some reason, I thought the winter was over. And the winter was mainly going to be comprised of that family of ARs that inundated the Eastern Sierra from December 15th through January 15th. But little did I know that the winter was just getting started. So we will be talking about the January family of ARs, atmospheric rivers, as well as the events that occurred in February and in March. So let's see, next, I think I'm on, so am I still on the front?
There you go.
Okay.
We're on slide 1 now.
So this is, California is well known as a state with extreme climate. We have either it rains cats and dogs, or we are shriveling up from drought and heat waves. And this pattern of climate extremes is going to continue for the foreseeable future, and will become, in fact, even intensified because of the warming climate. Next slide. Next slide.
Further, Sue.
Oops. Huh. So the talk will, so Galen is the second slide up.
The one with the figure of wet, dry, or the one with Joker meme?
Okay, yeah. Yeah, great. Okay, thank you. We'll get this figured out. So this talk is going to cover these topics, the atmospheric circulation that created this onslaught, nonstop winter, and it's still continuing to this day. The upper air patterns really have not shifted. You will see some ridging coming up, for example, this weekend, but a return to unsettled weather next week and into the foreseeable future. We'll talk about deterministic versus ensemble models and which one to use for short range and longer term weather forecasting on a personal level. I'll talk about and compare the winter of 2017 and 2023 precipitation. Then we'll switch gears and get into avalanche forecasting with some history of where avalanche forecasting started in the United States and in Alta, Utah, and talk about the contribution that Monty Atwater made to the profession, and with a list of factors that are still being used today. We'll talk about rain on snow, how rain moves through the snowpack, and the resulting wet slab avalanches that are the predominant avalanche type observed this winter. And then we'll look at some case studies of the major storms of this winter, the January 9th through 10th, the end of February storm, the March 10th through 13th, and the March 28th to 29th storm, because each one of them had distinctive characteristics and with distinctive avalanches. Next slide. So the first thing I get to do is point out what a lot of us have talked about this winter is back in November, the climate prediction centers came out with their seasonal forecast for the winter. And this is what it looked like. Wet over the Pacific Northwest, dry over the Southwest, and in Central California, kind of equal chances of either above or average precipitation, but mainly, you know, the mean, the average. And then next slide. So that was November. And after December, the long range forecast shifted to reflect what was going on. And to be fair, these are probabilistic forecasts. So what it really means is that the tendency towards drier conditions will be prevalent in the Northwest, with the dice being loaded towards wetter conditions over the Western US, and actually with kind of equal chances there in Northern California. And actually this has played out this winter, but I do like to, my favorite Edward Abbey quote of mine is "Nature bats last." And in this case, Mother Nature won, NWS long range forecast 0. Next slide. So I created these these composites to illustrate the fact that really over the course of the winter, the upper air circulation, the upper air flow has really not changed much. And this bears out because we've had frothiness and storm after storm after storm from actually November, Veterans Day, through March 29th, and then some unsettled weather after that. On the upper right hand figure, that is January, and that area of blue indicates colder than average temperatures rather than precipitation. And in February, you can see a blocking high in the Gulf of Alaska, and that created a very wavy trough ridge pattern that brought very cold air into the state, followed by March, which had anomalously low temperatures over the West Coast and very cold storms in March. Next slide. A closer look at this reveals, this is for an individual date on December 10th. You can see the pattern, the amplified pattern, where cold, lower pressure is parked off the coast, and that lower pressure brings with it a lot of cold air, with a ridge on the out more towards the date line, and a ridge over, blocking ridge over the East Coast, which at that time was experiencing a heat wave. Next slide. And at the end of January, if you recall, we did have a break. We had several weeks of relatively dry weather and more seasonal type temperatures. And that was due to a blocking ridge, which is more of the standard feature that we see in a La Nina year or a dry year. Next slide. And this is back to April. We're back in a colder temperature, lower geopotential heights over the West Coast. And this will continue through April at least. Next slide. This is a comparison of October through February precipitation for both 2017 and the same period for 2023. And interestingly, the 2017 image shows record wet conditions extending from central Northern California across northern Nevada into Idaho and Wyoming. In this year, 2023, the record highest precipitation is isolated to Mono County, a little bit in the Reno area, a lot of heavy rain and snow in the eastern Nevada, and then some centered in the Wasatch and then northwestern Colorado. Now, one of the reasons that we are not seeing the full extent of the precipitation anomalies is that this just goes through February. And in March of this year, we got more snow and precipitation than any of the previous months. Next slide. And was it cold? Yes, it was cold. And we were not record cold, but certainly cold, much colder than normal, usually about 5 to 6 degrees Fahrenheit. And precipitation, again, for our period, that December through February period, shows higher precipitation amounts in little bit in northern Mono or Inyo County, and then northern Mono County. Next slide. So one way for me to keep track of the storms, because it all became a blur in January, one after another, is to plot the precipitation, the daily precipitation by month. And you can see in December, there was some precipitation, and the X or the Y-axis shows the amount of precipitation in inches. And precipitation, as I'll continue to refer to in this talk, refers to the liquid, the amount of liquid water that's measured. And that can come in the form of rain, as well as in the water content contained in the snowfall. In 2017, we can see that February was the biggest month, and in terms of precipitation, with a very extreme amount of precipitation in February, early February, first week of February, where an extreme Category A atmospheric river event impacted the area. On the top plot, you can see most of the precipitation came in March of this year. And for those of us who live in the snow, we had shoveling and more shoveling and snow blowing and snow removal issues. One little factoid is a friend of mine up in at DRI estimated the weight of the snow per shovelful, per cubic foot of snow when he was shoveling snow in January off of his roof was about 40 pounds per square foot. So for those of us that had some shoulder issues, this certainly explains it. Heavy, dense snow in January, and actually mainly throughout the winter with a few exceptions. Next slide. So again, I kept track of storms based on the avalanches that occurred. And in December was an early season snowpack. It was already cold, and we were starting to get a hint of what was to come this winter. This is Wilson Butte on the left, and this is a natural avalanche. It was not triggered by the Caltrans howitzer or avalancher. And you can see distinctive crown lines, a step down to weak snow at the base of the pack. In January, we had extreme precipitation, especially in January 9th and 10th. And that created a very distinctive, remarkable wet snow avalanche that came off of Mount McGee. And that is me in one of the debris piles. It flowed like a slinky toy from the McGee Creek Trailer Park. It paralleled Old Crowley Lake Drive for about half a mile in this oozing wet snow, dense, and with quite a bit of blue ice within that avalanche debris. Very unusual avalanche, even for Mount McGee. Next slide. In February, I keep February storms place marked by the Moto Lake avalanches that crossed 395 and have isolated the people in Mono City. SCE power lines were damaged in the avalanche. And in mid-March, another remarkable rain on snow event occurred with large spectacular avalanches. Next slide. So here's the daily precipitation from the weather plot at Mammoth Mountain Ski Area. It's at the Sesame Street study plot. And this is monthly precip. This is breaking down the long period graph of the previous slide into, so we can really see what happened when. End of December, we had this pretty good significant storm, the New Year's Eve event. In January, we had just nonstop for 2 weeks, one atmospheric river after another. February really didn't get going until the end of the month with a nice break in February, which I think people tend to forget that we did have a nice break in February, which was preparing us for March. And you can see March, there was more snowfall, many more storms than in January. And in March, it was a little bit different because we had amplified ridge trough patterns that brought a lot of cold air in that interacted with subtropical moisture. And the result in March was this very chairlift on Mammoth Mountain. And all ski areas in the Eastern Sierra experienced these colossal snowfalls and colossal snowpacks. Next slide. So let's talk about atmospheric rivers for a little bit. This is winter of 2021 and 2022. And there's no atmospheric river events except for that one event in January of 2020 21, where we had the one storm wonder that gave us all the precipitation for the entire year. In January of, or the winter of 2022, we had one major storm, one extreme atmospheric river event that happened in October, towards the end of October. And that's the one that left good part of the snowpack, started there and then followed by subsequent storms, but really nothing, no atmospheric river events to speak of. Next slide. This was 2017, the winter of 2017. Many of you who are here remember that as a very active weather pattern that where we had quite a bit of snow in January and in February. Numerous atmospheric rivers. The most predominant one in 2017 was the moderate, and the categories of atmospheric rivers range from weak to exceptional, and that is both by the amount of vapor transport in the column of air in the atmosphere, and also the duration. So an atmospheric river of moderate intensity that lasts for a long time may be kicked up into the strong category just because it persists for many days. Next slide. And this year, we really got quite a few atmospheric rivers, maybe not quite as many as in 2017, but these were mainly in the moderate range and one exceptional range, exceptional severe extreme atmospheric river that happened towards the end of December. And that would be the precursor to the New Year's Eve rain on snow event. And by that time, by mid-January, we were all burned out, those of us who live up here in the snow, and we were done. We were done with winter by that time. February, we got a break. We had one atmospheric river, and then they came back in March. And Dr. Daniel Swain of UCLA wrote, "As disruptive as this year's events have been, we're nowhere near to a plausible worst-case storm and flood scenario for California, with the worst possible scenario being an event similar to the Great Flood of 1862. And that is a possibility. It's always a possibility of an event that extreme happening, and that those likelihoods of a large extreme event like that it's increasing. And we saw what we underwent in January. It's believed that if that atmospheric river pattern had continued for another week, we would have reached the historic 1862 precipitation levels. Next slide. So what does all this ARs mean for the Eastern Sierra? Well, we've got a record-breaking snowpack, and this is for the end of March. And next slide. And historic water contents in this snowpack. And this is a table of the Mammoth Pass course, and we've exceeded 1969 and 1983 and 2017 by quite a bit, by 15, 20 inches. The question now at this time of year is snowmelt runoff, and we're in a way, I'm hoping this unsettled pattern continues with some cooler than average temperatures, because that will prolong the runoff period rather than having a heat wave that could really increase flooding, especially in the Central Valley. Next slide. Let's change gears now and talk about avalanches. avalanche forecasting has been around since the 1950s, and forecasters of today owe a lot of our processes and forecasting processes and what we look at in forecasting for avalanches from work done in the 1930s to 1950s by a man named Monty Atwater. And he was a snow ranger in Alta, Utah. And Little Cottonwood Canyon is, as well as the town of Alta, Utah, are plagued with avalanche activity, big avalanches. In fact, it's going on today. A Little Cottonwood Canyon was closed. Now it's Big Cottonwood Canyon is closed due to both natural and control avalanches. Monty Atwater came up with a list of 10 contributory factors for avalanche occurrences. Next slide. And one of the reasons he did this was because the town of Alta was getting wiped out by avalanches. Next slide. So Monty Atwater was quite a character, and he loved to shoot explosives. He loved to shoot the guns. And some of these quotes are attributed to him. The old adage of never use one stick of dynamite when two will make a better boom was his motto. He was also affectionately known as Senor Boom Boom. These are the contributory factors towards avalanche formation that he came up with. And this is specific to Alta. Did quite a bit of work that verified that these indeed were the factors for forecasting avalanches in Alta. Next slide. And here they are, old snow depth, new snow depth. You know, at least 12 inches of snow need to fall before and be associated with wind. And precipitation intensity with settlement. Notice the wind. His criteria for wind was 12.5 miles per hour. Well, I don't know of that storm that had or in this eastern Sierra that has winds of 12.5 miles per hour. And then you've got your temperature trends. And this was written up in a research paper done by Ron Perla and published in 1970. Next slide. So I've taken these, as all forecasters do. We take those contributory factors and modify them for our own specific snow climate. And in the Eastern Sierra, generally we have a maritime snow climate, which is typified by temperatures averaging around 20 to 30 degrees during the winter and frequent rain events. And with the warming climate, I'm seeing two different types of storms in every winter. Storms that come in warm that are usually atmospheric rivers that produce quite a bit of rain. And then we also have winter storms, are the more traditional winter storm that originates in the Gulf of Alaska. And they're cold, and we have experienced both types this winter. And some of the modifications that I made was that I really look at the precipitation intensity, and that means how much mass is falling on the snow, what is the rate of loading on that snowpack. And precipitation intensity for a rain on snow event, it doesn't take very long of this higher intensity precip to create big avalanches. And another thing that I will look at is convective bands, and we had experienced that quite a bit this year, or narrow cold frontal rain bands. Snowfall intensity 1 to 2 inches an hour with critical wind, and the winds generally have to be 25 to 35 miles an hour. Another thing that's really important, since I deal with individual avalanche paths, is the path history. and also temperature. For winter storms, it's a little bit different. New snow depths still need about 12 inches of new snow. And this new snow type, dry snow crystals, stellars, precipitation particles, graupel. Average density of 8% or greater, and that's for the Eastern Sierra. 8% density snowfall is considered great powder skiing, whereas in Alta Utah, where they can get 5 and 6% density storms. Precipitation intensity is longer to create avalanche, large avalanches. So I only need for this about 1/10 of an inch an hour for a longer period of time, 8 to 10 hours, to where you start seeing large avalanches that could threaten roads. Okay, next slide. And the next step in my process is I have to evaluate the likelihood of an avalanche reaching the road or community. So I'll identify the avalanche weather, climate, or the weather snowpack, the storm characteristics coming in. I'll start looking at the numbers and then evaluate the avalanche hazard and either issue warnings for road crews in Inyo and Mono County. Mitigation that we have available to us in this area is avoidance, road closures, and evacuations. If we were in another snow climate, or if we had a series of winters like this strung together, it would be possible to have the interest and the political will to purchase some avalanche mitigation tools, such as an avalancher for specific areas. But for now, we are limited to evacuation and avalanche warnings and road closures. Next slide. So this is a weather product that I use a lot for avalanche forecasting. And this was really exceptional storm, this January 9th through 10th storm. And you can see on the upper left-hand plot, this is accumulated precipitation in inches over a time period, about a 6-hour time period. And this is centered over Mammoth Mountain, about 9,000 feet. And you can see on January 9th, the model forecasted for Mammoth Mountain about almost 5 inches of precipitation in a 24-hour period. And this is very, very high intensity precipitation rates. And the snowfall that comes with that is on the lower left column, lower left plot. And you can see 60 inches of snow is expected to fall in that same time period. And the ensemble means are the solid lines, and the members of the ensemble are the lighter lines. So you can see even in an ensemble, there's really good agreement initially for the first 24 hours of the time period. And then you get more scatter in the precipitation and snowfall amounts. That is because ensemble forecasts are generally good just for the first 24, 46-hour period when you're forecasting for precipitation. Next slide. So if we're considering that 0.1 inch an hour threshold for avalanche activity for drier snow avalanches, you can see for the January 9th through 10th storm that these rates were very, very high, but higher than Mammoth Pass is the precipitation intensity at South Lake. And this is a remarkable sustained period of high precipitation rates. And then a little break in the storm, and then on December 10th, there was another round of precipitation. And that resulted in, next slide, please. That resulted in a large avalanche that occurred in Aspendale in a well-known avalanche path called the East Slope. And the photo on the right, you can see the remnants of the Shat internet tower. And so we know exactly when that avalanche occurred because all the internet went down in the community. So it happened at 9:30 in the morning on December 10th. This was this avalanche that started out at about 10,500 feet as dry snow, and then entrained all this wet snow that was created by the rain. And in Aspendale, they picked up about 8 inches of precipitation in 24 hours. So a large avalanche, this is the debris took out this house on the upper left-hand corner of that photograph and extended down to the second house in the middle of the photograph. Next slide. That same storm created a large, tremendously large avalanche off of Mount McGee. And this again started at higher up, a very small starting zone area, but as it traveled down the path, it entrained a lot of snow right around the 8,500 to 9,000 foot elevation, and tremendous volumes of snow. And that avalanche went towards 395 and then took a 90-degree turn and paralleled 395 for at least a half a mile. And this is me in the debris with photos taken by Claude Fiddler on that day. Next slide. So what does rain do when it hits a snowpack? Photograph on the left shows what rain does when it hits the snow on a Lake Tahoe house roof. My friend Ben Hatchett saw an opportunity while shoveling to do some little bit of snow science and cut out a column that was backlit. And you can see how the rain moves through the snow in these little flow channels called flow fingers, flow paths. And it seems to go through these layers in the snow without being impeded by the layers, which is conventional thinking that rainwater hits a buried layer in the snow and it ponds and spreads out laterally before finding an area of weakness before it continues to move down through the snowpack. In this case, it doesn't appear to do that. On the snow surface, you can see these runnels that rain will do. And this is an excellent photograph from Nancy Fiddler taken by their house in Crowley Lake after a rain on snow event. The runnels are formed by as the snow moves under the snowpack and forms these preferential flow paths. Next slide. So not to be undone, I sprayed coffee on a column of snow at my house and took photographs of how the snow moved and the time that it took to travel. And the snow is cold. The snow temperatures were -5 to -6 degrees centigrade throughout that column of snow. So you can see it ponded at the interface near the snow surface and then made its way through, found another area of lower density snow, fresh snow, and then the flow proceeded to find its way farther down into the snowpack. And the time from the application of the coffee, which I sprayed 100 sprays, which is equivalent to about 0.5 centimeters of water, it took about 3 minutes to get to travel to the January 9-10 layer. So it moves quite rapidly through the snow. Next slide. So I was introduced to a PhD student who's working on wet snow movement through snow with my friend Dr. Ben Hatchett up at DRI. She's doing her dissertation on this. And this is some of the results of her spray tests. And you can, she measures how far and how fast the rain or meltwater simulation travels through the snow in the different layers. And depending on the application, the snow, if there's more coffee sprayed on the snow, it travels deeper in the pack. Also, the temperature of the snow appears to influence the rate of movement. Next slide. And these are results of her findings on this particular series of experiments. This has implications, next slide please, to wet slab avalanche problems. This year we've seen many more wet slab avalanches than previous years, and these are very difficult avalanches to forecast for, particularly because they're difficult to predict the size, because the wet snow can entrain or pick up more wet snow as it travels down an avalanche, and they can create these enormous avalanches, such as we saw in Mount McGee. And to be able to forecast for wet slab avalanches is really important when you're dealing with roads and, for example, Tioga Pass, when they start clearing Tioga Pass. But they're very, very difficult. So I'm hoping that this work with these coffee tests will provide some insight. And I'll be working with Anne and Ben on applications of their work to slab avalanche, wet slab avalanche forecasting. Next slide, please. So after January, towards the end of February, the weather pattern changed. And I know these ensemble plots are difficult to read. So I've added some red lines to indicate the ridging, which is the up in red, and then the bottom of the trough, which is in dashed red lines. So this is a different pattern than what we saw in January. And the storm character definitely changed also. Next slide. So we had, because of the position of the trough being a little bit farther south and the flow being meridional rather than zonal flow straight across the ocean, we got some pretty intense precipitation that came from the south. Next slide. And at the end of February, we had an event that created these, overloaded the snowpack there above Mono Lake. And my friend Randy Walker was going into work from Mono City into Lee Vining. He's the Caltrans yard supervisor there in Lee Vining. And he came across this on February 27th. So that avalanche occurred on February 27th after the storm had left the area. There was very little accumulation on that Sunday until the avalanche just started to occur at the end of the day. And while he was there witnessing, calling me because he was so excited, and he knows I'm such an avalanche nerd, he said at least 20 other avalanches ranging in size from very small to large that spontaneously avalanched from the slope above. And that's what created the series of avalanches that covered 395. So as part of our effort to help out with the road clearing and restoration of power, Tom Painter of the Airborne Snow Observatory agreed to do an overflight over Mono Lake. And this is the result of that ASO imagery. This is a snow depth map with the colors blue indicating snow depths of 3 meters. So you can see where this map where these avalanches cross 395. You can see the snow depth is 0, red, along 395, but with piles of debris that are greater than 3 meters, so that would be 18 or 19 feet of snow. Another ASO product that was helpful for operations was this view of snow depths from looking west above Mono Lake towards the 395 corridor there. Pretty remarkable technology. And we were really fortunate that the ASO people agreed to do this for the road clearing efforts as well as to restore power to Mono City. Next slide. Mid-March was memorable for another rain on snow event, and the 13th of March, the precipitation was picked up, 9 inches in a couple of days at the Mammoth Mountain ski study plot. And this is a resulting avalanche that occurred on the Rock Creek Road above the Narrows by the Aspen Creek campground. This is not going to be an easy task to remove. I think the county is planning on using a bulldozer to get through this. There's more slides above, more towards Rock Creek Lodge and Rock Creek Lake, of course. Next slide. So that high precipitation intensity also triggered other avalanches in the area, and all large. Kearsarge Peak, taken from an aerial photo. I believe it was from Kevin Kleinfelter's overflight. I'm not sure, but you can see how it starts out as a small avalanches, but then it entrains tremendous amount of wet snow as it continues down. Very destructive avalanches. Next slide. And then the South Fork Road on the way up to South Lake and Bishop Creek, that avalanched 4 times this winter. And this is the most active avalanche path in both Inyo and Mono counties in terms of crossing roads and threatening snow removal operations. Again, this was the result of that December 10th through 12th rain on snow event. Next slide. And finally, we ended up the season, the last major avalanche cycle of the season was at the end of March, a very low precipitation event, but it was cold. And as a result, we got a different type of avalanche. These were storm slab avalanches. They failed within the new snow layer, and they traveled a long way, and walking through the debris was very soft and was very easy to travel through. And they extended all the way down into Bishop Creek. So they ran the full extent of the historic path. Next slide. And this impressive water vapor loop. You can see the eye of the cyclone or the subtropical storm there off of the coast of Oregon, Washington. It was further off the coast than the previous event. So the Bay Area did not get the extreme impacts that it did from the previous storm in March 20 to 22. And next slide. And again, this is the March 29th storm again. Cold air that brought nice dry snow. Next slide. So kind of a wrap up here. At above average precipitation, and with the highest precipitation over the eastern Sierra and the southern Sierra, as well as the coastal ranges farther south. It really did miss Northern California. And the average temperature, the coldest temperatures of the year were right in the Mammoth, Long Valley, Tom's Place area. Although it still was cold over the whole entire eastern Sierra. And finally, next slide. So I've talked, this has been a wide-ranging talk, and I hope that people understand that there is both atmospheric river events and cold storms, and each of these types of storms influence the avalanche character. They also present avalanche forecasting headaches, whether you're a backcountry forecaster or a roads forecaster. And one thing we have taken out from this winter is this wet slab avalanche problem is of great concern going into the spring. Because with deep snowpacks that are cold, as the rain, or as hopefully we don't get another rain on snow event, but as the meltwater percolates through the snow, it'll reach all of these different layers that have occurred as a result of these storms. And we're really not sure which layer will avalanche, or it could take several days of water ponding on that surface layer or on that buried layer to avalanche. So they're very tricky to predict both in time and in size. And to wrap up, I just want to, this is kind of a treat. I got these photographs last night from Todd Calfee. They just came out from the April 1st Kearsarge snow survey. And this is the old style way of measuring snow. And even though there's ASO overflights to tell you how much water's in the snowpack, Department of Water Resources and the big water cooperators in the Central Valley see the value of getting on the ground manual snow measurements. And imagine what it would be like to sample the snow that's that deep. You can see the snow tube and all those lengths assembled on that, and that's Pat Armstrong. And Pat Armstrong on the right hand side, peeing up out of the Kearsarge Lakes towards Kearsarge Pass. And further imagine coming up onto the cabin after you've skied from below Onion Valley over Kearsarge Pass, and that's all you can see of the cabin is that stovepipe. And imagine the effort to dig down to get into the cabin. So it's probably very well insulated. And finally, the last slide. Questions. That's a season's worth of snowpack on that outhouse. Okay, Galen. Thanks for that.
Myself. Thank you, Sue. Wow, I'm just kind of like in awe of all the photos you just shared. So we can start our Q&A. I'm going to open the chat up. Kind of glance over this. Because I was like busy changing slides for you and managing the meeting. So new skill achieved. So it looks like there is one from Connie Miller in regards to Pogo Nip and Mono Lake. And she really loves your coffee experiment. I've seen other people on Instagram do that, by the way. So thank you for explaining that. Connie's asking, can you speak to the underlying processes for Pogo Nip and any effects on avalanche processes on adjacent slopes? And that's referring to the Mono Lake Basin.
That's a really good question, Connie. And yeah, thank you for attending. That's a really good question. I'm not sure I know the answer to it. I know that the Mono Basin was people didn't see the sun for weeks at a time. And whether pogo nip fog could influence the snowpack properties at the surface, one thing that comes to mind is the pogo nip is fairly low, close to the lake level. I think one thing that I could say is that because of the cold temperatures that persisted for so long, that really encouraged the large temperature gradient to form in the snowpack, which would promote the weak faceted snow that seems to be the most of the snowpack this winter. And these cold temperatures have made the snowpack weak, and that could help explain why Randy Walker saw multiple avalanches occurring, 24 hours after the last snowfall, which would be an event that you might see in the Colorado Rockies or Montana, the Rockies there. So that doesn't really answer your question, but thanks for that, and I'll look into that. Thank you.
See, Heidi Anderson says, thanks, Sue. Great to see your mug. Great presentation. So I will also read accolades out of the chat. So
Okay.
I have a question, Sue. In preparation for snow melt, are there any local groups doing monsoon forecast that might affect like debris flow, water flow of the mountains, and like its effects on the snowpack in the mountains? I'm just thinking of like what it does in the White Mountains when we get really big monsoonal storms. So
yeah, the pattern of monsoon and the area which the monsoon is affecting seems to be changing also. Rather than being centered over the four corners, we had a lot of monsoonal rains last summer, and the research is not, there's not a lot of it on this shifting in the monsoon at this point, but I know it's being heavily studied. One thing that's going to affect the rate of melt and flooding would be how the temperatures and as well as the increasing solar radiation. If we have a hot spell, above average temperatures for a week, the upper parts of the snowpack are really going to melt and create flooding. What we want to avoid, what all the agencies are hoping will happen, is a delayed snow melt, cooler temperatures. So when the snowpack or when the snow melt that's generated at the surface finally reaches the ground, then the ground has the opportunity to absorb that snow water, and rather than running off.
okay, thank you, Sue. Jeff Holmquist, our resident scientist, has a question in the Q&A here. He says, thanks, Sue. All kinds of great stuff. It seems like we didn't have many dry periods for development of faceted grains. Are there, in fact, fewer buried faceted grain layers this year?
Well, despite the fact that we saw very few sunny days, when the sun did come out, we did get a lot of near surface facets, and they were subsequently buried. The other thing that promotes faceting this year again is the cold temperatures. And the snowpack at my house a couple days ago when I did those coffee tests was -5 and -6C, and that's at 7,000 feet. So the higher elevations, I would expect to see colder temperatures, and those colder temperatures are going to persist much longer in a deep snowpack than they will at 7,000 feet. So an incredibly faceted snowpack this year, and I think just the simple answer is that it was just cold.
Sue, let's see, we've got two more here. Another one regarding monobasin and avalanches from Colette. The multiple avalanches in the Mono Basin, could the avalanches trigger other avalanches, like a sequence of avalanches?
Yeah, great question. And I think that's what happened when what Randy Walker observed is what we call them sympathetic releases. And they occur when you have a widespread faceted layer and one avalanche triggers another avalanche because the mechanism of avalanche release is the collapse of a weak layer. And if you have a weak layer, that wave of collapse will propagate to over slopes, over ridge lines, into the gullies, adjacent gullies. And I think that's what happened at Mono Lake that day.
Thanks, Colette. Thanks, Sue. Let's see, we have one from Stephen Moore saying, I recall hearing that this winter was a La Nina. How does this phenomenon of all the atmospheric rivers relate to that, if at all? My recollection is that El Nino is more associated with atmospheric rivers. Is there a relationship in that regard with this extraordinary year?
That's a great question. I knew it was going to come up. So historically, the largest flood events in California occur during La Nina years. And El Nino was associated with warmer, wetter conditions, and La Nina was associated with drier and colder conditions. You know, as the climate is changing, these relationships are changing also. And, you know, this is an excellent example of a stupendous snowfall year that occurred in the La Nina. And if you talk to the Weather Service people, they will say, well, one of them will say, well, we don't do ENSO here, meaning the El Nino, La Nina oscillation, because the effects are much larger than at a regional scale, at a mountain range scale, because these effects are global. And the global effects, of course, influence other global effects, and the relationships are changing because of the warming temperature and also because of the loss of sea ice in the Arctic. This is really creating havoc with the polar jet and the pattern of the polar jet. The polar jet has slowed down and it can become stuck in a very wavy pattern and persist for days. And this is what you see on the ground when this happens, are these extreme cold snaps in New York or in the Midwest. We haven't had that here this winter. It's just been persistently cold. So again, you know, the El Nino, the best way to put it is the El Nino and the La Nina, they stack the dice for a better chance for, in La Nina, colder than average temps, and maybe, I don't know about the precipitation and the thing. And the El Nino stacks the dice for a more southerly jet stream that would steer storms into Southern California, Arizona, and New Mexico. But again, these relationships are changing and due to the warming climate.
Thanks, Sue. Thanks, Stephen. We have a question from Noli. Hi, Noli. Noli asks, given the amount of snowpack in the Sierra and the avalanche hazards, what are the risks with the Inyo White Mountains? Highway 168 comes to mind as one area that could be impacted, but are there any studies involving this mountain range?
Oh, that's a great question. There are no studies. There was a study done back in the 1960s, and it had to do with sublimation in the White Mountains. And because of the very, very cold and very, very dry air in the White Mountains, the snowpack doesn't persist as long on the ground because most of it sublimates. And by sublimation, I mean it goes from the crystal phase, the solid phase, directly into water vapor. And so you have the snowpack loss, even though you may not have any snow melt. And that would certainly influence the type of snowpack structure that you would have, and mainly consisting of very weak, faceted grains. I have done some skiing in the whites, and other friends have, and they've confirmed that. It's very tricky avalanche conditions there. Definitely need to be very aware and think that you're skiing in the Rockies. Even the smallest terrain features could slide and be a large slide. I wish there was studies. I'd love to do one, but so far it hasn't happened. But definitely, heads up if you're skiing in the whites in terms of avalanche hazard.
That's good to know, considering that we have to try to get up there this season to check everything out. Thank you.
Well, one thing that also happens in the White Mountains is the wind. And so you'll have impenetrable wind slabs crossing the road up to Crooked Creek and other areas. So it will be quite an operation.
Snolly, thanks, Sue. Let's see, we can go until about 7:30, and then my scheduled meeting for Zoom will expire. I do have an announcement to make before we commence. WMRC will be participating in this year's Bishop Sunrise Rotary Earth Day in Bishop City Park on Saturday, April 22nd. So you're welcome to stop by and say hello. We have some goodies and just see what we're up to. This is part of some outreach that we are conducting. I also want to thank everyone that participated in the lecture series this season. This is our last talk for the season. I'd like to thank Sue for volunteering to do this lecture and having to reschedule it with all of her hard work involved with our insane winter this year. This talk is being recorded and it will be posted to our website and our YouTube channel at a later date. I should be sending out emails about that. Let's see, Stephen. Okay, now I'm going to read the accolades off to you in the chat, Sue. Stephen says, terrific, engaging, thought-provoking presentation. Colette says, thank you, great talk. Anyone else, you're welcome to ask a question or any kind of insider input. Now is your chance.
Well, that was great questions. And yeah, I'm glad. Thank you all for showing up and being engaged and interested and supporting this lecture series.
It's always thankful. Thank you, everybody. Well, let's see. With that said, I guess we'll wrap it up for the evening. And Sue, I'll touch base with you tomorrow just to see if we need anything else. And that being said, I bid you all adieu and have a good evening. Night, everybody.
Goodbye.